Welcome to the part 2 of understanding data. So we will look at different ways to analyze the summary of a variable in this video. Basically, we'll look deeper into each variable in as part of descriptive analysis. So to understand data, we look at the summary of each variable, and summary of a numerical variable can be seen, so let's first create a sample. So set.seed is for the purpose of reproducibility of the data. So we are using sample function to create or generate random variable which has 200 data points. So let's look at the summary. Summary function, we can use summary function to look at the summary of the numerical variable. So what it gives is that the minimum value, the maximum value, then median and mean, as we've discussed in the previous video. This is 25th percentile and this is 75th percentile, first quartile and third quartile. So we can also do the box plot of this numerical variable to look at the graphics of this variable. So you see this box plot, and this line represents the median, which is 100.5 here. This represents third quartile, which is 150.25, and this is the first quartile, which is 50.75, and this entire range is in IQR, interquartile range, as we discussed earlier. So we'll continue with the summary part. Now let's look at the summary of a categorical variable. So again, we will generate one random sample data. So set.seed for the reproducibility. So this sample and letters is a function. Basically, it has all the English alphabets from A to Z. So you can give the index. So this is how you use letters in capital letters, each letter in capital letters, then square bracket. If you want to use all the alphabets, then don't mention any number inside. If you want a particular set of alphabets, then so I've taken first 8 alphabets from this, and then we want 200 data points. Replace means this sample will use only those first 8 alphabets but 200 times, so by replacing each of the alphabet. So then we convert this variable, because this will give us a simple character variable. We want a categorical variable, that's why we use factor, as we discussed earlier, and this works well in R, so we will convert this into factor. So summary, so again the same function we use here. What this does is it gives you the count of each categorical value in the categorical variable. So A has been repeated 32 times, B 17 times, and so on and so forth. And if you use this table function, this will also give you the same result as summary. So we can do pie plot, plot the pie chart for this, and this is what you get. So it will give you percentage wise plotting of the same numbers here. You can see A has got the maximum section here and portion, and then we can also do bar plot. So this is the bar plot for each letter. You can see it has plotted separately. A has got the highest, and then likewise you can see this is the E is supposed to be the second highest, no, H. So you see H 28, and yeah, E is second highest, that's true. E is second highest with 30. So you can see that this is how you look at the variable, and summary gives you the overall picture of each variable, that categorical or numerical variable. So now we can also look at a summary of a data frame. So for that we'll create a data frame. So as we've already created X and Y variables in the previous slides. X is numerical variable, Y is your factor variable or categorical variable. So we use this function data.frame to create a data frame in R. So again we use the summary function, and what we get here is, see, this is the way it represents. So X is again the same value which we saw: minimum, maximum, median, mean, and first quartile, second quartile, and Y will give you the counts basically, and other 37 because it gives you the first, I think, 6, 1, 2, 3, 4, 5, 6, and the remaining 2 letters which have got the least values not shown here by R. What is outlier? Now outlier is an extreme observation in a data set. So let's say we have a data set like which has a value varying from 1 to 10, and suddenly there is one value which is 200. So this 200 value is far from the average, and it can affect the mean of that data. So outlier does not mean that it is a bad thing. In fact, the whole story can lie in that outlier. Outlier can tell the core of the story. That is also possible. So it's not that outlier is always bad. So this is the formula of outlier. Interquartile range, as we saw in the earlier, so which is quartile 3 minus quartile 1. So that gives us that. And then outlier is basically these are the two formula. Any value which is 1.5 times IQR below Q1 is outlier, or 1.5 times IQR above Q3 is outlier. That's how we define outlier. So, and Q1, just to reiterate, this is 25th percentile, and Q3 is 75th percentile, as we saw earlier, right? And this is the difference, and 1.5. So let's just take an example. We'll add one outlier to the previous example of X, which is numerical. An outlier is always for a numerical variable, not for categorical variable as such. So again, we'll do the box plot of this variable and see this gives us the value here. So this is the outlier here because it is far from here. So this value 1.5 times into IQR. So Q3 plus this, and this is Q1 minus this. So let's look at descriptive statistics for different groups. So we can also see the relation among different variables in a data set. For that, we will create a random data. So I have just created a random data set.c is for reproducibility. Again, it's basically a clinical trial data that I've randomly generated here using R. So treatment means no treatment or new treatment. Medicine means placebo, medicine 1, medicine 2. Placebo means no medicine given. And eudaimonia is basically a mental state of a person which is not disturbed. That means person is happy and person does not have any mental disturbance. So we are measuring eudaimonia in the scale from 0.1 to 2, and then I've incremented by 2, and then again use sample to create this, and then put it in a data frame. So treatment, medicine, and eudaimonia. So this is the data, clinical data. I've named it clinical data. And if you see the summary, because of the constraint of the space in this slide, I have not provided the result. You can do the same thing and you will get the, you can see the summary on your system. Now aggregate is a function which shows us, like, this is how we look at the relation between different variables in a data frame. So you use this aggregate, and then you use you can, this side on the left side you have eudaimonia, because this is what we are measuring. What is the effect of medicine on eudaimonia, and then tilde, and then data you provide. These are the arguments. Data, so clinical data. Function means different functions. You can also write summary here, but we are using mean. We are seeing the effect of medicine on the patient in terms of eudaimonia. So you see medicine, eudaimonia, and then medicine 1 and medicine 2 and placebo, because these are three options we have here. So you can see medicine 1 has maximum effect on the patient. It improves the mental state of a person, because the higher the value of eudaimonia, the better the mental state of a person. Medicine 2 has least effect on that, and again placebo is also doing pretty well. That means without medicine also the patient is doing pretty well, but medicine 1 definitely has a higher upper hand. So we can again do the box plot using the same formula. So to see the here, instead of medicine, we are looking at the treatment. What is the effect of the treatment on patient in terms of eudaimonia? So you see no treatment has performed better than new treatment in terms of on eudaimonia on patient. So now let's look at another way of looking at the, again, understanding the relation between different variables. Now here, earlier we saw eudaimonia as against one variable. Here we are using both the variables and then see what happens. So you see it gives you this result here, and it segregates data based on medicine as well as treatment. So the first is medicine 1, 2 and placebo, then medicine 1, 2 placebo. This 3 is for new treatment and this 3 is for no treatment. So you can see again that somehow medicine 1 and no treatment has performed extremely well. And in the first one again, because medicine 1 is doing pretty well, that's why the result is this. And so basically medicine 1 has somehow has better result, and and no treatment. So this combination has performed the best, giving the highest level of euthymia to the patient. So this is how you analyze, different data. So this is another way of looking at your data. Again, so by is another function. You provide the data. This argument indices again treatment, and then function we are using summary to see the summary. So you see, if you do this, what it does is it segregates the data between this treatment, new treatment, no treatment, because this is the index we are using, right? And then you can see that no treatment somehow has a better performance than new treatment. See, the median here for no treatment is 1.5, while median for new treatment is 0.9. And then again, if you see here, you can also look at these parameters. Here, medicine 1 and 2 have been given to more patients. So more patients have received medicine under this new treatment, 8 patients, and 2 patients have received no medicine, just placebo. And here, again, you have more patients receiving placebo as against medicine 1 or 2. But anyways, this is how you look at this. Is a generic data I've just randomly created. If you have real life data, you can get a better overview. So this gives you the overview of what data is telling us, and a quick way to look at the story in the data. Although there are many other ways to go deeper into the data. Now correlation. Let's look at what is correlation. Correlation is basically a single value which gives us some idea of how two numerical variables are related to each other. So then positive correlation means both the variables move in the same direction. What it means is if you increase the value of one variable, the value of other variable also increases. Then negative correlation means they move in the opposite direction. That means if you increase the value of one variable, the value of other variable will decrease. So this is the now to know the how to calculate correlation. For that we need to know what is covariance. So covariance is defined by this formula 1 by n minus 1 because we are using sample data. If it is population, entire population, then 1 by n. So there are two variables, right, x and y. So again we subtract mean or average of entire x from each value of x, and then we do the same thing with y also, and then multiply them and vary from 1 to n for each value, and then we take the sum of them. So multiplying each the subtracted values and then taking the sum of them and dividing the entire total by n minus 1. So this gives us the covariance. And the correlation can be defined as covariance divided by standard deviation of x into standard deviation of y. We know what standard deviation is, right? We've seen it in the previous video. So again, we look at sample data. We generate random sample data like x and y. See, using same sample function here, 1 to 20, 100 data points. We use replace and then 31 to 50. So 20, 20, but 100 data points. And then we use function core. This is for correlation in our x and y. See, so the value is very small and it is in negative. So this is negatively correlated, but it's weak. What is the meaning of weak and strong is that if the values correlation value is closer to -1 or +1, the correlation is strong. It could be negative if it is negative, positive if it's positive, but strong if they are closer to -1 or 1. If the correlation is closer to 0, then it is weak. So the correlation value varies from 0 to 1 or 0 to -1. That is the scale we use. So now there are special values in R we need to understand. When we are dealing with the data, you may come across these symbols, or a keyboard keywords basically. So INF means infinity. It could be plus infinity or minus infinity. So when you get to see this particular keyword in R, that means it is infinity and could be the result of some calculation such as n by 0, where n is not 0, like we already know mathematically, right? Another value is not a number, NaN, capital A, small a, capital N, small a, capital N again, nan. That is, it's a reserved keyword to represent that this isn't a mathematically defined number. So suppose by doing some calculation you are making mistake 0 by 0 or some code error or whatever it is, or if you've got a data where you see NaN, that means it's not mathematically defined number. So that's what it means. Then not available, Na, it indicates that the value is missing in a variable. So let's say there is a variable which contains age group, age of each person, but in one row there is no age. That means it, and if it is written NA there, that means the number, the value is missing, and it could be maybe because we have lost the data while importing the data, or the person has not provided the data, or whatever may be the reason. Now null means it's an extended version of NA. In fact, it what the difference is there, here it is missing because we haven't been able to receive the data, or person has not provided something, or we've lost in between. Null means that the value doesn't exist itself. So it could be, you can take any real life example, that value doesn't exist in the universe, in our universe, so that means it's null. That's why we use this null. So thank you so much again for your patience and watching this video. I think this video has been helpful. If you like this video, like, share and subscribe. Thank you so much.